All right, guys, so factoring step by step. So again, we're focusing on factoring because this is a big one for Math 2 and Math 3. So if you don't understand it, you're going to struggle. So this is something you want to make sure you get. So the first example and first video today is with a GCF. And this is taking our magic diamond or our X, our ACB chart, and then understanding how to find the GCF in this problem and trying hopefully to break it down where some of this makes sense to you that you can do it by yourself. All right, so look at this bad boy. Look at our problem for 4x squared minus 16x plus 12. Ideally, you would like the a value. And when I speak of a value, I mean ax squared plus bx plus c, which is the standard form for a quadratic. So you're looking at those parts, and we're talking about that 4 in the front. Ideally, you would like that to be a 1. So when you're dealing with factoring quadratics and not just GCF, ideally you want to try that 4 in hopes that that 4 is a GCF throughout the entire problem. Now, right below that, I have written 4, 16, and 12. Ideally, you're looking at the factors. So how do I get 4? The things that are divided into 4 would be 1 and 4, 2 and 2. And that's all for 4. And 16 is 1 and 16. 2 and 8, 4 and 4, and then we're done because that's all for that one. And then 12, we have 1 and 12, 2 and 6, 3 and 4, and we've got all of those. And so as far as the GCF, so once we found the factors of all three of those numbers, that's the greatest common factor. So they all have a 2, they all have a 1, but the big guy is a 4. So that's going to be your GCF, the greatest common factor. So if I pull out a 4, then what I'm left with is x squared minus 4x plus 3. Now, so that's just GCF, factoring out a GCF. So you take your 3 numbers and you make sure there's not an x back here too, because sometimes they'll throw an x back here, but that would mean this x, as far as in quadratic is concerned, would have to be to the 3rd power. So if this is to the 3rd power, there was an x squared and an x here, then we would also be able to pull out an x. But in this case, our last term does not have an x, so all we can do is deal with our numbers. Now, we're going to plug this, we're going to hold on to him, don't forget about him, but we're going to plug this quadratic into our magic diamond. So the magic diamond was where we were finding the factors. These two guys were factors, so the ones in the middle were factors. The one on the top was a multiply, so multiply. The one on the bottom is the add or combines to be that number. So when I'm looking at my quadratic, x squared minus 4x plus 3. They're going to multiply together to give me 3, and they're going to add or combine together to give me a negative 4. Now, your future math teachers are not going to draw these circles, and they may or may not necessarily use this x. Remember, I showed you this x is the same thing as this diamond, except it's not drawing circles. So 3 goes on top, negative 4 goes on the bottom. A term that they may use in another class is this is whatever a times c is, and this is your b value, always. Okay, so now our ACB chart is what a lot of the math teachers at Pinecrest call that table. So it's the multiples or the factors of a times c, which in this case, again, is a 3, that add or subtract to give me that negative 4, that b value. So that means I have 3 and 1, and that's it for this one. And is there a way that 3 and 1 can be combined to give me a negative 4? If they were both negative, if I add them together, I get a negative 4. So then those are our factors. So in this case, we only have one set, so we don't have to decipher between them. Negative 3, negative 1. And I remember in the previous videos, I told you if your b is negative, the big factor will always be negative. The small one's the one you just have to decide whether it's negative or positive from that point forward. So then I have a negative 3 here and a negative 1 here. Now, because a is 1, once we factored out that 4, all we simply do is take these two numbers out and we write our factors. So x minus 3, x minus 1. Now, don't forget, because if this is all I have written down, if I FOIL or box that back together, that's not going to give me what I started with. So don't forget your GCF. This is factored completely. Also, I would suggest check your answer. So I can take these two guys back because I was looking at some of our work that we've been submitting and I'm not sure we even understand the multiplying of the binomials. So box method, x minus 3 on top, x minus 1 on bottom. Now I'll do FOIL underneath it. If you are using photomath, they are probably doing something similar to FOIL that they're calling distributive property. So make sure if that's what you're looking at that you are copying it correctly. So first is x times x, which is x squared. Outer, so x times a negative 1. It's going to give you a negative 1x. So that's our outer. And then inner, so that negative 3 times x will give us a negative 3x. And then last but not least, our last, which is at negative 3 times that negative 1, gives me a positive 3. Negative 3 times negative 1 gives me a positive 3. So if I pull this out, I end up with x squared minus 4x plus 3. Now, that's not what this problem started with, but it was what the problem was after we factored out that GCF of a 4. So if I put the 4 back in front, now all you can do is distribute, which gives me 4x squared negative 16x plus 12. Now that indeed is the original problem. Let's see if I can get it both on the screen. Yep, that we started with. So 4x squared minus 16x plus 12 is our 4x squared minus 16x plus 12 that's up here at the top. So that means we did indeed factor it right, and we can say that that answer is correct. So we did it correctly. We factored. All right, guys, that's factoring with a GCF.